Hello, second graders. My name's Monica, and I'm a certified teacher in Tennessee. I'm glad that you joined me today. We're going to do a number talk together. Number talks are a way to develop number sense by thinking about all the different ways you can add and subtract numbers mentally. You shouldn't need any manipulatives or a pen or paper for this activity. Let's get started. All right, I'm going to write some expressions down here, and I want you to think about what you think the answer might be. And I also want you to think about how you are thinking about solving these problems. Let's get started. Here's the first one. The first one is 7 plus 10. Have you thought of an answer? Great. Brandy, can you share with us what you think the answer is to 7 plus 10? Brandy says she thinks the answer is 17. Do we agree or disagree with Brandy? I see everyone agrees with Brandy. The answer to 7 plus 10 is 17. Brandy, tell us about how you were thinking about this problem. Okay, so Brandy was thinking about a 10 frame. And she was picturing a full 10 frame and another 10 frame with only 7 spaces filled. 1, 2, 3, 4, 5, 6, and 7. Oops, 7. Okay, Brandy, when you were picturing this, how were you thinking about the problem? How were you thinking about answering it? Okay, so Brandy says that she started with the 10 and then just counted up 7 more. So 10, 11, 12, 13, 14, 15, 16, 17. Very good. Did anybody else think of it differently? Okay, Carlos, why don't you share with us how you were thinking about it? Carlos says he knows that any number, a single number, plus 10 is just going to be one of the numbers in the teens. So can you give us another example of that, Carlos? Okay, so he says another example might be 8 plus 10. 8 plus 10 is 17. And 5 plus 10. 5 plus 10 is 15. So a single number plus 10 is going to be one of the tens, one of the teens. Okay, let's look at the next one. 7, again, plus 20. Madison, would you like to share what you think the answer is to 7 plus 20? Madison says that she thinks the answer is 27. Do we agree or disagree with 27? Okay, it looks like everybody agrees. The answer is 27. Madison, tell us about how you were thinking about this problem. All right, so Madison said she was looking at a 100s chart and she saw the number 7 and knows that each row on a 100s chart is 10. This is 1 through 10 to 20, 30, 40, and so on. So if she looked at the number 7 and knew she needed to add 20, how many 10s should she count up? 2 10s. So here is 7. This is 1 10. This is 2 10s. 7 plus 20 is 27. Can we check that just to make sure? Here's 7. And now we need to add 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we counted up 20 spaces. Just moved down 2 rows. 2 sets of 10. Very interesting. I like that strategy. Let's look at another one. Here's the other. 7 plus 30. Do you have an answer? Great. Carlos, tell us what you think the answer is. Carlos says that he thinks the answer to 7 plus 30 is 37. Do we agree or disagree with 37? It seems that everybody agrees. 7 plus 30 is 37. Can you tell us how you were thinking about that? So Carlos says that he was thinking about the hundreds chart again. So he started at the 7 and he added 3 sets of 10. 10, 20, 30. And saw that the answer is 37. 7 plus 10, 20, and 30 is 37. Is there something happening here that looks like a pattern? Let's talk about that a little bit. What are some of the patterns that you're noticing in these 3 equations? Okay, all right, so someone said they noticed that in each one we keep starting with the number 7. So one of the add-ins is 7 in every one. And someone else just told me there's another 7 in each of these equations in the sum. So in each of them we have 7 plus a number equals a number that ends in 7. 7 plus a number equals a number that ends in 7. 7 plus a number equals a number that ends in 7 again. Wow. What else do you notice? Okay, so someone else just said that they noticed that all of these numbers that we're adding to the number 7 are all ending in 0. And they're moving up by 10s. So 10, 20, 30. All of these numbers our numbers are multiples of 10. So when we count by tens, 10, 20, 30, 40, we are counting by the tens. Those are multiples of tens. These are friendly numbers because they make it easier to add a number to one of the multiples of tens. They're easier numbers to work with. Okay, let's do another set. Here we go. The next problem in this set is 28 plus 10. Do you have an answer? Good. Let's see. Susan, can you tell us what you think the answer is to 28 plus 10? Susan says she thinks the answer is 38. Do we agree or disagree with Susan's answer? It seems that everybody agrees. 28 plus 10 equals 38. Susan, tell us how you were thinking about that. Oh, so Susan said she was just counting on. So, if she was using a number line and she started with the number 28, did you count on by ones? Susan says she counted up by ones. So 28 plus 10. We'll have to keep track of those. 28, 29, 30, 31, 32, 33, 34. This is getting really messy, isn't it? It's also kind of hard for me to keep up with how many I've counted up. How many have I counted up so far? Yeah, not enough. I've only counted up 1, 2, 3, 4, 5, 6. And I lost track. I'm glad that you were able to do that. Susan says she was using her fingers, and so that made it a lot easier to keep track of. Well, did anybody else solve this and get the correct answer, like Susan, but in a different way? All right. Addie, can you tell us what you did? All right. So Addie said that she was looking at the hundreds chart and she found the number 28. Where is that? Where is that number 28? Here's the 20s. 28. So she started with the number 28 and just added 10 more. So when I'm adding 10, all I need to do is go down 1. 28 plus 10 is 38. Very good. Let's think about that using some place value blocks. So here we have the number 28. Hold on, I'll get my 8 cubes. 21, 22, 23, 24, 25, 26, 27, and 28. So here we have 10, 20, 28. And I'm adding 10. So there's my added 10. And my new number now, the amount that I have now is 10, 20, 30, 38. Okay, let's try another one. The next one is 28 plus 50. Are you struggling with this one? Just a little bit? All right. Scott, can you tell us what you think the answer is to 28 plus 50? Scott says that he thinks the answer to 28 plus 50 is 78. Do we agree or disagree with Scott? All right, I see that some of you agree with Scott that the answer is 78, and some of you are not sure. So let's take a look at how Scott thought about this problem. Scott, tell us how you were thinking about this. Okay. Again, Scott was using the hundreds chart. He started with the number 28, here it is, and he added 50 or 5 tens. So 28 plus 1 10, 2 tens, 3 tens, 4 tens, 5 tens. 28 plus 10, 20, 30, 40, 50 is 78. What are you noticing, again, about these two problems? What's the pattern? Yeah, I see the same type of pattern that we saw before in the last group of problems. We see this first addend ends in an 8, and our answers, the sums, end in an 8. And the numbers that we're adding to each of the 28s ends in a 0. They are multiples of 10. Let's try another one. We'll do 28 plus 31. Do you have an answer? Okay. Let's see. Matt, can you share with us what you think the answer is to 28 plus 31? Matt says that he thinks the answer is 58. Do we agree or disagree with 58? Okay, I see that several of you are disagreeing. So, can you tell me why the answer is not? Why is it not 58? Oh, that's interesting. So Sarah says it really shouldn't be 58 because the problem is not following the same pattern as the others have been. What's different about this problem than the other two? Yes, I see. So in the other two, we were adding by multiples of 10, 10 and 50. This time we're not adding by a multiple of 10. We're not adding by 30. We're adding by 31. That's great. That's really interesting. Good way to pay attention to those patterns. Okay, Sarah, how about you tell us, what do you think the answer should be? What is the answer to 28 plus 31? Okay, Sarah says that the answer is 59. Do we agree or disagree with 59? All right, I see most of us agree that the answer to 28 plus 31 is 59. Sarah, can you tell us how you were thinking about that? Okay, so she used the chart, hundreds chart again. She started at the number 28, and she was adding how many groups of 10? 3. 28 plus 10, 20, 30. Here we are at 30. This was the answer that Matt said he thought the answer was 58. What now, Sarah? I see. So Sarah was saying that we counted up by 30 and then one more. So the answer is 59. Very good. This strategy that we've been doing today is called adding up in chunks. When we're adding by multiples of 10, we're adding up by chunks of 10. This time, in this last problem, 28 plus 31, we added up in chunks of 10 and then a chunk of ones. So, thank you so much for being here with me today and thinking so hard. I love how you were noticing the patterns in the problems. If you'd like to do more with this strategy, more practice, you will find extra practice problems in the parent and teacher packets. Thanks for joining me, and I'll see you next time.
I've written the math expression 3 plus 6. If you have something to write with, you could write your math expression. Now I want to model the expression 3 plus 6. So I'm going to get 3 counters to model the number 3. You do that. Good job. Let's model the number 6 together. 1, 2, 3, 4, 5, 6. Now let's think about our math strategies. What could we do to find out how many we have in all? Yes, we can use our counting on strategy. We can count on to see how many we have in all. Where should we begin counting? I'm hearing you say, let's start with the number 6. But why the number 6? Because it's the biggest number and it will be a more efficient way to count. It'll be faster. So let's do that. 6, 7, 8, 9. 3 and 6 is 9. Great job, first graders, using your math strategies to find out how many we have in all. Let's try another. Our new math expression is 3 and 7. Let's model the expression 3, and 7. 1, 2, 3. You model your number 3. Now let's model the number 7 together. 1, 2, 3, 4, 5, 6, and one more is 7, right? So how can we figure out how many we have in all? Yes, we can use our counting on strategy, and we can count on to find how many we have, 3 and 7. Is there another way? I'm hearing someone say we can use what we know about 3 and 6 is 9 to get at 3 and 7. How can we do that? Yes, 7 is one more than 6. So if 3 and 6 is 9, then 3 and 7 is 10. Yes, it's a way to make a group of 10. But let's be sure. Let's use our counting on strategy to check our thinking. 7, 8, 9, 10. Were we correct? Were we correct? Yes, we were. 3 and 7 is 10. You guys used 2 different strategies on this one. We did use our counting on strategy to check our thinking, and then we also used what we knew about 3 and 6 is 9 to understand what 3 and 7 would be. Great job.